Good afternoon, everybody. My name is Caroline Key, so I am a client engagement advisor at YORhub. And today we're here to introduce James Gibson, who will deliver the flood risk webinar. So James specialises in flood risk and sustainable drainage. He's led the design and delivery of local, national and internationally renowned projects and is recognised as an expert in this field. He's the lead designer of Yorkshire Water, the Environment Agency Hull and East Riding's Living with Water initiative, which aims to protect the city and its surrounding areas from the risk of future flooding. He's a former regional director of AECOM, and he was part of the leadership team that delivered the Jeddah stormwater drainage programme in Saudi Arabia, which was a £1 billion project involving dams, channels and drainage systems designed to protect lives and reduce flood risk. He's also a chartered engineer and chartered water and environmental manager and a member of the Chartered Institution of Water and Environment Management and holds a master's degree in civil engineering. So I think we'll all agree that we are in good hands with what James is going to present on today. So I'm going to hand over to James at this point. If you do have questions as we go through the webinar today, if you'd like to put those into the chat box and then we'll visit those at the end of the session. Please do ask as many questions as you have in there. I'm more than happy to answer those, and we've got time to do that at the end. So over to you, James.
Thank you. Afternoon, everybody. Caroline kindly introduced me. I'm James Gibson. I look after the civils team within Allen Wood & Partners. I enjoy my job in terms of flood risk and drainage. Whether that puts me in a small category or not, I don't know. But it's my pleasure today to talk about flood risk and SuDS. It's a high-level introduction on flood risk and drainage based on my experience more recently dealing with the Living with Water schemes and the challenges that brings, but also just to take people through what consultees may be looking at, how developers look at things, how water authorities look at things. I feel I've got a good experience of working in multiple projects and multiple clients. So if you've got any questions, I can try and help with them. Just a bit about Allen Wood & Partners. We were established in Hull in 1968, and that is still our head office. We've expanded our horizons towards Leeds, Lincoln, Scarborough, Sheffield, Teesside and York. Teesside's our most recent offering, which opened up probably 18 months ago. We are currently running at around 115 technical staff with support staff in the background, and we have a turnover around 12 million per annum with a clear growth strategy over the next few years. Our core services, Allen Wood himself started off as a geotechnical engineer and structural. That is still very much the core of our business. We do focus as well on civil engineering, as it says there, drainage, flood risks, drainage impact assessments, Section 104 designs for water authorities and NAVs. We do the highway works, but we've also got a really strong team who do the temporary works designs and building surveying that we run out of our offices. We do geotechnical and environmental works, mainly out of our Sheffield office. We have a good specialism in heritage, having one of the only a few CARES registered engineers. So in terms of flood risk and drainage, getting into the policies, they are, to say the least, quite dull to read. However, they do clearly are important documents. National Planning Policy and its predecessors, I worked under Planning Policy Guide, PPG, and PPS 25, I think it was back in the day. I started doing flood risk and drainage works on the back of working for Yorkshire Water and coming out of an AMP3 back in the early 2000s, transferred towards more developer-led schemes and more planning policy. We have a very good set of policy documents, although their interpretation is very varied across the country based on my experience. What East Riding may say is acceptable may not be acceptable in Oxfordshire and vice versa. We use fairly simple elements of flood risk mapping. We have national minimum standards for SuDS, which is a fairly recent publication. back in June last year. Codes for adoption, I'll touch on that later, but that's SuDS for adoption in the new guise. People may or may not be used to dealing with local authorities from a planning perspective, but my go-to people are the lead local flood authorities. Working in the areas that I do, my driver is to establish good relationships with the guys and teams that run those authority elements, and try and engage them early. They're informed themselves by the strategic flood risk assessments, development control standards for flood risk. Each one has its nuances. As I said, Leeds is different to East Riding, maybe different to Doncaster. So getting to know them, having the experience of dealing with each of them is critical. Making our lives easier is my main focus, but also making the consultees' lives easier. So Rob, for example, at Hull, I was on the phone with him recently, and that is part and parcel of what I feel is good engagement, good practice, and getting to know the standards, getting to know the engineers and officers who can approve and give you some guidance as well on their local knowledge. In this area, we're also surrounded by and covered by internal drainage boards, Beverley, North Holderness, York Consortium, Selby. We have some, again, really good local knowledge on what can be done and what can't be done. And then we have water authorities and NAVs, new assets and variations as they're called. NAVs are a different form of a water authority, but have the same permissive powers to adopt, to maintain and look after sewerage. They are quite popular at the moment with developers, but Yorkshire Water in this area, United Utilities over in the northwest, Northumbrian in the northeast, they own most of the public sewerage in the vicinity. We tend to apply for them for connection discussions and discharge rates. But for adoption, I'm seeing a definite swing towards NAVs. Whether that swings back towards water authorities in the future will remain to be seen, but there's commercial benefits and maybe program benefits, but overall the customer experience shouldn't change. So very high level assessments. On screen now are various guises of flood maps. Some are old, some are new, some are available now on the government website. If you type in flood risk DEFRA, you'll get a link. You'll be asked to put in a postcode, and then you can draw around your site, but you can get the flood risk data that is available to them, and there are numerous forms of this data that's available to anybody who types in the postcode in the website. What governs development in flood risk terms is flood zone 1, 2, and 3. 3 is split up into 3A and 3B, with 3B being functional floodplain and areas that are designed to flood every so often and more frequently and really shouldn't be developed. Flood zone 1 is the lowest flood risk area, and this is from rivers and sea, fluvial and tidal, as they call it. Flood zone 1 is the area that you should try and direct development towards in a sequential approach, and take the lowest area to develop in first. The map to the top right-hand corner is Hull and East Riding. So when I'm saying try and develop in flood zone 1, it would suggest that Hull shouldn't be developed in, and that's not the case. There are very specific requirements for development and flood risk in Hull, but you can see it clearly follows the principles of where there's water, there's a risk. Flood zone 2 is the middle banding of that risk, and flood zone 2 is the highest. So if you've got a site in flood zone 3, it carries a higher chance of flooding than it does in flood zone 2, and so on. The bottom right-hand figure on the slide covers the climate change impacts. Historically, as in 3-4 years ago, this wasn't published. So the flood data that we obtained would include climate change, but it wasn't shown on a map. Climate change impacts are due to either sea level rises or rainfall intensity increases over the lifetime of developments, and it states the obvious, but the extents of flooding will get worse as climate change impacts are experienced. Some areas which you can see in the dashed data don't include climate change, so that needs probably more of a discussion with the local authority and with the Environment Agency. But this is our starting point for any quote, any site I look at from a flood risk perspective. Are you at risk of flooding, and if so, to what extent? Not only do we have to look after or look at fluvial and tidal rivers and sea flooding, there are a host of other sources of flood risk that could impact developments and sites and individuals' properties. So on the top left, we've got surface water flood risk. It used to be a blue map with various shades of blue. It's developed recently, probably a few months ago, into orange for whatever reason, but you can see that it's a thematic map based on various depths. The mapping itself looks at the 1 in 30 year chance of occurrence, the 1 in 100 year, and I think the 1 in 1,000 year. And it also gives you an assessment on the impact of climate change, very similarly to the fluvial and tidal mapping. So all of that is painting a picture of literally flooding from rivers and seas, and now flooding from surface water. And surface water flooding is that falls out of the sky rainfall. It's based on topography. There is a small allowance. I'm not exactly sure how it's calculated, but there's an allowance for some drainage within the area. But if you were planning a scheme up in this northeast corner, you would try and mitigate the overland flood risk elements by either relocating a development away from that area if you could, or by raising a finished floor or putting flood resilient measures in. The map to the bottom right is reservoir flood mapping. That again used to be just a big blue picture. Now it's red hatched and changes fairly frequently, but that's just covering a dry day scenario should the reservoir fail or overtop, where water will go to in a dry day without the addition of rainfall and fluvial and pluvial events. And that reservoir flood risk is always got to be considered in your assessments. However, in our experience, the risk of it happening is, the consequence of it happening is high. If a reservoir fails, then clearly there's a lot of hazard that can come towards a development, but the chances of it failing are quite remote. Reservoirs, in the true sense, are governed by the Reservoir Act, and that was based on various failures of reservoirs years ago. So the UK are very well equipped to assess reservoir failure likelihood. So just because you're near a reservoir doesn't mean it's a no-go to development. It's just you've got to consider it, and there are various themes and owners of reservoirs. I'd expect most of the reservoirs in the area not to be private, maybe Yorkshire Water or EA related, and it covers a whole host of small water bodies up to large water bodies, but it's something that we have to consider under the NPPF requirements. Once you've done desktop studies based on DEFRA information, we move towards what they call strategic flood risk assessments. Each local authority has to do their own strategic flood risk assessment. That informs flooding from the same sources, but considers it on a more local and nuanced basis. So you can see from the top left-hand corner, top left-hand image in the slide, this is Gould's strategic flood risk assessment. East Riding commissioned that separately to the wider SFRA. This is an extract from the East Riding flood mapping service, which I think is really, really good. But you can see there are some significant depths of flooding predicted in Gould. That then governs mitigation and development in Gould. It is a low-lying area. For those who don't know, it's right next to 2 or 3 water courses that are all at flood risk, and it's in the Humber Basin. So Google has a special SFRA. So if you're again looking towards development, you've got the tools that are available from a DEFRA perspective, but you've also got local authority tools. In looking at sites recently for developers, I've been using the Doncaster SFRA, which is the bottom right image. That is showing groundwater flooding. Groundwater flooding doesn't tend to cause a lot of issues. It tends to cause issues in valleys where groundwater may be artesian and above ground level. But clearly, if basements are planned or temporary works and deep drainage is planned, then groundwater is clearly a risk and an impact that could be assessed at the planning stage. So Doncaster produced their own mapping of that risk. Green is low, red is high, and therefore that helps me inform perhaps a development potential where a developer may want 2 stories of a basement, and actually, no, that's not going to be appropriate in a particular area because groundwater flood risk is high and requires mitigation. So that's very high level site-specific information, but available to anybody to look at and interpret as they will. As far as I know, the EA, the Environment Agency, don't publish flood level data. You have to request it. There's a variety of timescales that you get the data back from. Some sites are quick, some sites are less quick, but this is, I think, for I want to say York and the River Ouse, and that is specific data. If I can just focus on these are node points and watercourse. So that River Ouse has been modelled in a hydraulic software. Each node has a flow associated with it at a return period, and the flood level is associated with that. So if we've got a site in this area, we would look at the nodes opposite, we would look at the nodes in general and say, for the 2% AEP, which is the annual exceedance probability, which is the 1 in 50-year event, what level would that be? And we've got for that particular node 10.5 meters above ordnance datum. If your site's at 12 meters, then clearly we're not flooding, but as that flow and flood level increases for the higher events, the 1 in 1,000 event, 1 in 1,000, it's maybe up at 11.7 as it says on the table. If you're at 12, then clearly you're not at risk of flooding, and that should be reflected in the flood maps. But does that include climate change? Does that include does it mean that you need to mitigate against the flood risk of that river and site-specific details? So this is more specific elements, more specific modelling, but clearly not every watercourse has a model. The River Ouse, big tributaries, big main rivers do, but a drainage ditch at the end of a field probably doesn't. That's not to say that you can't work it out, but clearly the risk of a drainage ditch flooding a site is probably lower than it is when you're in the centre of York, and clearly people know about York flooding fairly regularly. All of the flood risk data, all of the flood information we collect, we present, we consider, and ideally we do discuss with the Environment Agency or the lead local flood authority. That informs our mitigation. There's not a lot of mitigation you can recommend other than the more straightforward ones of lifting the finished floor level to protect the inhabitants of a building. You can flood resilience and flood resist. Resistance is physical flood barriers preventing water getting in. But in Hull, for example, where flood depths could be over 1 meter, a flood resilient strategy, resistant strategy isn't appropriate because that in itself could lead to structural issues with the building. So we'd look at a flood resilience strategy and let water enter the building, but make sure that materials used within it can be brought back into use more quickly. The people living there or using the facility can use it more quickly. So there's good DEFRA guidance on improving the performance of flood resilience and buildings in flood-prone areas. When developing in flood-prone areas, clearly the risk, the primary focus is risk to life. So there is vulnerability classes within the national planning policy framework: highly vulnerable, more vulnerable, less vulnerable, depending on whether it's a care home, a hospital, a house, a school, or whether it's water compatible, which might be an open area for SuDS. Developing in a floodplain still needs consideration, even if it is an open space in a flood-prone area. That would be water compatible, and clearly there would have to still be though mitigation against flooding and maybe warning signs around informing people using the open space. But any development in flood zones tends to require a flood risk assessment that's proportional to the scale of the risk. So moving on to surface water drainage and drainage in general. It used to be that there were 3, expanded to 5 hierarchies of disposal. That's now been expanded in June last year with the National SuDS guidance. And in water stressed areas, which given recent weather, probably most areas are water stressed, the focus is now on rainwater harvesting. Can you use that for non-potable use, irrigation primarily? Can you use it for potable use, albeit that's less what's the word? It's more challenging than non-potable use. But we've had schemes in Hull recently that have had to consider rainwater harvesting, which we've not really considered historically. So that's a primary requirement, and to provide good reasons why we can't do it on sites. The image to the bottom right is a SuDS planter that doesn't recycle flow for non-potable use, but it does slow the flow down. That's a planter that has got medium within its soils and gravel. So we're getting water quality benefits. We're getting slowing the flow, and we can also reduce the volume of water discharged out into the sewer system. So there'll be an overflow from that device into the ACO down there. So then we get back to what I think is probably well known by the audience, the infiltration drainage principles. Soakaways, historically, they used to be brick-filled pits. Nowadays, they're a little bit more complex and cleaner than that, whether it's a geocellular system, whether it's a manhole, whether it's a granular surround. Getting water to go back into the ground is more sustainable than discharging it elsewhere. We're very much guided by BRE 365. So anybody who has a consultant or keeps on getting battered by, you need to do a BRE test, that's the reason. Building Research Establishment test number 365. It's as dull as it looks in terms of digging a hole, filling it with water and timing it. In my experience of watching a lot of these, a lot of them don't work, and I've had occasions where water levels have increased, not decreased. So the areas that we tend to work in the north aren't great. However, we do have schemes that where we have limestone ground conditions and infiltration works really, really well. And this it tends to be a discussion point during the LLFA meetings. Do we need to do one in Hull when we tend to know the ground conditions in Hull aren't great, but there are pockets in Hull that may be appropriate. So this is the reason why we specify BRE 365 tests. Number 3 in the hierarchy is watercourses, mimicking land drainage perhaps, or a new connection, as you can see on the top left. These can take various forms, from the River Hull in Hull to a drainage ditch that's bounding a field boundary. Depending on where you are, you need licenses to do so, either local authority license or land drainage license, IDB licenses, or Environment Agency permits. You tend to do this without, not at a free discharge, and by that I mean you've got to flow control the rate to the equivalent greenfield rate. So if that grassed field you can see on the top left-hand corner currently discharges into that watercourse at a greenfield rate, that's in the order of 1.4 litres per second per hectare, very, very low rates. It's not the case that you can just develop and then send surface water into a watercourse unrestricted. You can do that in a tidal area. You can do that into the sea because of its infinitesimal nature, but watercourse discharge has to be done at the greenfield rate, and brownfield if you get dispensation from the local authority and from the IDB perhaps. In terms of number 4 and number 5, preference is surface water sewer, and then a combined sewer if we can't find a surface water sewer. This, as I touched on at the start, is governed by Yorkshire Water in this area, United Utilities, Thames Water. I think the top left-hand image is a combined sewer, brick, Victorian. That discharge into that sewer would require Thames Water, in this case, is approvals, and they would also govern a restriction and discharge rate, and the position for connection as well. In recent standards, foul water sewer discharge was accepted. That's been, I think, removed. There are issues with foul water sewers, obviously, which I'll touch on later, but the hierarchy should be to reuse it, to get it back into the ground, or to discharge it to a watercourse, and these last two, number 4 and 5, are less favoured. So the guidance that we primarily use is the SuDS manual. It is a fairly old document now, and I understand it is being renewed. I'm sitting on a SuDS panel with Syria and local partners on a SuDS tool, IQ SuDS, which will develop and enable quicker assessments on the benefits of SuDS for consultees and contractors, consultants, and general public. So the SuDS manual is the element that governs our designs and outputs and informs development in general from a drainage perspective. I touch on and I bang on about the 4 pillars of SuDS quite a lot, because historically we've concentrated on that northwest quadrant, water quantity. If you discharge at a greenfield rate, you have to balance excess flow on site. That's a quantity element. It reduces flood risk. It maintains flood risk and hopefully reduces it, because you're controlling flows for the lifetime of the scheme. You're balancing flow, you're allowing for climate change impact, but that's always tended to be the focus. It results in either large basins or large storage tanks. The other 3 elements of SuDS, the biodiversity, the amenity, and water quality, have always played second fiddle, but I think that is certainly changing now. The biodiversity certainly is being considered more hand in glove with the biodiversity net gain requirements. Amenity is at the forefront of developments and residential schemes, making it an environment people want to be walking around and interacting with. And then quality, I've read some shocking research recently on large motorway related potentially polluted runoff, which is diffuse pollution. It's not really discussed, but if we can get water quality enhanced by filtration and absorption and passing it through SuDS and the treatment trains that they require within the SuDS manual, which has always been there, I think that's where we're now being prompted and probed to deliver a SuDS scheme that isn't all about quantity. It's about all 4 pillars and delivering a holistic scheme that local flood authorities, the Environment Agency, the developers, and the consultants can be proud of. Touching on SuDS elements themselves, this is very traditional, very commonplace historically. Interceptors, they trap oils and fats and oils and hydrocarbons and settle out sediment. It's an end of pipes solution. It's a car park discharging into this. These are still appropriate. There are settings in more of an industrial commercial sense that these are appropriate still. They can still provide water quality benefits. They have a finite lifetime. They need operation and maintenance, but people are used to seeing these and it's still appropriate. However, we're more used to getting these discussion points on schemes, bioretention areas. Flow comes off the carriageway and is filtered through what is effectively a planted up area. For anybody who's been to York recently, in the York teardrop site at the back of the station, the roads run off to really some good SuDS around there. The York Ring Road, again, there's some wildflower planting and some swales that deal with runoff from the road, and that's quite high risk area, massive, huge traffic movements, huge amounts of vehicular movements in the day, and the risks therefore of pollution are quite high. These aren't designed to manage 100-year storms and big events. These deal with the day-to-day 1-year events that carry the highest pollution. So you can see there the inlets on one side. Water will filter through the grass or the planting, the bushes, through the soil into a perforated pipe below the bioretention area. That affords it water quality benefit. You've got amenity benefit because it looks nicer. You've got ecology benefits as well. What you don't have a lot of is the water quantity. So you're not storing a lot of water. You might only store 2 inches, 50 mil of water in the bioretention. So it's land hungry from a developer perspective, but actually you could incorporate that with traffic calming. And it's got an overflow into the sewer system to deal with the larger events. Anybody who's driven down the motorway with French drainage on the side of it, this is very similar or exactly the same. Different way of saying a French drain. It's a filter trench with a granular layer that water can flow off the surface of the carriageway or the hard standing, the car park, wherever, through the granular material. It isn't particularly nice to look at. However, you do get the water quantity benefits. There tends to be a 30% void ratio in the stone. So flows can be stored in the filter trench. They're certainly treated by the granular material. But in terms of benefiting amenity and biodiversity, it's a bit of a stretch. This, I think, is great in terms of its appearance. However, from a developer perspective, it may not be great because it takes up a lot of land. Swales are traditionally shallow. The one in the picture is pretty deep, to be honest. I think that was designed not just to convey flow from A to B, but to store water as well. So it's more of a linear storage feature and a basin than it is a swale. However, you can see there, you can plant it, you can add real value for, and that ticks all of the 4 pillars: quantity, quality, biodiversity, and amenity. But clearly that's taken away 15 meters of potential developable land. So planning developments, densities may need to be tweaked if large scale SuDS like this are required. There's many ways to, if we have groundwater issues in terms of, is there a risk of groundwater coming up through the base, we can line the swales with impermeable membranes. If the swales themselves are very shallow, we can underdrain them with perforated pipes. So swales are, I think, quite beneficial. And in Lincolnshire, for example, these are fairly commonplace. Certainly as you head more south in the country, swales are probably more seen with highway authorities and accepted. As we move up further north, they're being encouraged, but in terms of design standards and expectations, we continue to work with local highway authorities on the adoption requirements, and again, each authority has a nuanced view of it. Permeable paving, again, similar to filter trenches, it's doing the same thing just in a more robust way. This is a personal achievement for Alan Wood and Partners. We're working, as Caroline said, with the Living with Water team and M Group on retrospective installation of SuDS. So we took this a few years ago from the tarmac street on the left and artist's impression on the right, and it is pretty much exactly the same as you can see it today. It's a permeable paved road. It's changed the philosophy. We've got a lot of storage provided within the granular subbase. We limit the flow back into the combined sewer at 2 points. So this was a flood risk reduction scheme, but with a very clear objective to try and include more green suds. In this case, greenery wasn't appropriate. The loss of car parking space was very, very sensitive. So to put in bioretention areas or tree pits, in the end of the day, wasn't agreed. However, we are getting water quality benefits. We are slowing the flow. We are storing excess flows. So from a flood risk reduction perspective, this is doing the primary job. Touching on this a bit further, because I've got first-hand, up-to-date information on it. It's not without its challenges. There were a lot of residents on the street, on a one-way street, that had to be catered for and obviously allowed in their houses every day. So management of that was particularly challenging by M Group and the contractors. But it's as simple as the section below the photographs show. An impermeable membrane that prevents groundwater ingress getting back into the public sewer, which is not permitted. A perforated pipe that conveys flow from A to B to a flow control device, and then excess flows are stored within the granular subbase that you can see. Again, an involved scheme with Hull City Council and their highway teams, who were really receptive and up for the challenge. Just in terms of material replacement, what do you need in the depots compared to how maybe you used to do road construction and maintenance? But that, for me, I think is a success in terms of flood risk reduction, and it's a matter of opinion, but I think it looks a bit nicer than the tarmac. I think people are used to seeing large attenuation basins on schemes, and they are bang for buck, very economical compared to buried storage. However, they are end of pipe solutions. Flow tends to go all the way to the basin. You get your water quality benefits if it's planted. You get more water quality benefits if it's a pond. You get the biodiversity and amenity benefits. The more planting and more elements, you make that look less engineered. However, it may prevent adoption if you put in too much planting and amenity space. So there's a trade-off between what a water authority or a NAV may adopt compared to what the biodiversity net gain requirements are. And again, bottom right-hand corner, there's always methods to prevent groundwater ingress to make sure that the capacity of the basin is there. You can turn the basin into a pond and have a permanent water level in it. Image on the right-hand side is directly from the SuDS manual. We spent an inordinate amount of time talking to specialists about gradients and depths of water for water quality benefits. However, that's got to be traded off by over-excavation and the cost of disposing of material that isn't able to be used for, the void that you create to create the pond isn't there available to be storing water. So it's not a quantity benefit, it's purely a quality and amenity benefit. Moving towards one of my last slides on surface water, the buried storage is traditional geocellular crates, the milk crate type that people see, whether they're wrapped in a permeable membrane or not. We've got oversized pipes, we've got precast concrete tanks. They're traditional. I like them. You know what you're getting when you put them in. They're historically proven. Certainly the concrete tanks are. However, absolutely no water quality benefits. Sorry, there are some water quality benefits because silt can settle out, but there's no biodiversity, no amenity, and local authorities, in my experience, are moving away from them. However, they are still part of the SuDS schemes that you can use. Layouts, as I touched on before, SuDS tend to be more land hungry than clearly a pipe and a manhole in the road. And that's just down to space use, topography, available areas, and what you can try and double up on. Permeable paving in driveways, for example, you're not increasing the space requirements, but you may change the material. You can still use permeable tarmac on lightly loaded areas. So it's not all doom and gloom from a space perspective. It's just got to be appropriate to what you're trying to achieve. I won't go into too much detail on drainage design itself, but our starting point is on the right hand side is a very light touch topographic survey. Where does the land fall to? Left hand side is an extract from Yorkshire Water Sewer. Where can we discharge into if we can't infiltrate, if we can't connect to a water course, if we can't reuse water on site? So we take those elements, we look at the ground conditions, we look at the connection points, and then we build up a scheme. This for a small house developer, where we maximise the use of permeable paving. And if I'm being honest, this is a couple of years old. I don't think we made the most of SuDS planters, for example, or bioretention areas. So there are always opportunities to add more, but there's the balance between program cost and developer ambition, as well as local authority requirements. And in this case, it was deemed appropriate that permeable paving was used to slow the flow, to balance excess flow, get the water quality benefits. In terms of developing that design to how it looked from the previous slide, we used micro drainage, and it's now infra drainage to do the hydraulics. The tables on the right hand side of the slide are the water quality indices that we use to demonstrate that water quality has been improved by the SuDS that we've used. So a typical surface, a roof, a hard standing area car park will have a certain set of indices. If you put in one kind of SuDS, you will reduce those indices and it passes or fails. It's a fairly simple tool. There are more complex tools for it, but I think that's an appropriate way of assessing water quality benefits. And the more SuDS you put in, clearly the cleaner the water that you'll discharge. Touching on adoption, not all sites are adoptable, but we do a lot of Section 104, which is sewer adoption under the Water Industry Act, governed by codes for adoption and Yorkshire Water specific nuances. If you're in the Yorkshire Water area, but new assets and variations have their own requirements as well. They may accept a deeper depth of water in a basin. It may be that there are less inspection fees to pay. It may be that the acceptance of a NAV is more advantageous compared to Yorkshire Water, and vice versa, as I said at the start. So these are the documents, and again, through experience, one officer's or one engineer's interpretation of these is potentially different to others. So again, getting to know people and the way that they view and work is just as important as the documentation and guidance itself. So summarising that whistle-stop tour of what SuDS can do, it does reduce flood risk. It can and absolutely can enhance water quality. The majority of SuDS, other than the bioretention that I mentioned, has a quantity benefit of reducing the storage or providing storage to balance excess flows. We certainly could use the green SuDS to enhance the biodiversity and dovetailing with B&G requirements and amenity, it goes without saying. The constraints definitely are space. Management and maintenance, you'd have thought, is maybe easier, but equally it's new. How do you maintain a swale with wildflower planting in it? Is that very different, absolutely, to a sewer and a manhole? Does that come into long-term cost assessments? I expect it should do. And is there a risk that we're unaware of? Perhaps over time silt will build up and that becomes something to have to get rid of. Is it any different to silt building up in a sewer compared to a swale? Perhaps, perhaps not. So there's the longer term aspects that still would need a bit of consideration. And my last thought before I stop is the foul water drainage, which I wasn't going to drop into the slides, but actually a lot of our schemes at the moment are coming under scrutiny from capacity of the foul system. Treatment works, which is on the left-hand side, are at capacity, or a lot of them are. We're seeing schemes that are being limited in terms of their development, maybe not starting until 2030 because of the next AMP period. AMP stands for Asset Management Plan Period 8. Yorkshire Water and the water authorities do that every 5 years to provide capacity, and it may be a limiting factor. You might tick off, I've got no floods at risk, or I've got manageable flood risk, I've got a manageable surface water scheme, and then you're stymied by foul capacity that you don't really see coming. So whilst it's not a planning requirement for foul, we always recommend that you get a pre-planning inquiry response and make sure that there is capacity there. You can't reserve it, but you can plan for it. And that is something that is catching larger schemes out, but also smaller schemes as well, and cumulative impacts of capacity and over the years that have impacted on the ability for the water authority to treat the water. So that is it from me.
Brilliant, thank you, James. A lot of information to capture in a short space of time. We do have a few questions which I'm going to open up now, if that's all right. So first one, within the 4 pillars of SuDS, how are you navigating water quality, amenity and biodiversity within schemes when compared to more traditional piped systems?
There's a balance always where perhaps a developer may want to deal with a traditional scheme. I take advice on the biodiversity elements. It's not not traditionally an engineer's bag. So the advice from an ecologist and what we can maybe get out of biodiversity net gain credit, I'm taking advice on that from them and dealing with it collectively as the team. The quality elements of it come out of a good amenity scheme will tend to be a good quality scheme, and it'll also tend to be a good quantity scheme. So I'm encouraging it. However, no two ways about it. Space is a premium. So if you've got a real dense site that you need to do 35 dwellings a hectare on, and you've got no chance, then it's a discussion we need to have with the planners and the project team.
Thank you. Next one is on the bioretention areas used in the slides, for example, what vegetation is considered to try and meet the water quality aspects? Obviously, not all vegetation helps remove pollutants and often would struggle to survive with high or moderate pollution levels if not selected carefully.
I'm not a botanist, but we would take advice from the SuDS manual, and you're right that, yeah, overlaid and grass over time with silt and hydrocarbon buildup wouldn't be appropriate. I deal with a lot of landscape architects who are already specialists in this area who give me advice. We've done the ones in Living with Water with a landscape specialist. So again, engineers training courses are there for us to attend, but we know our limitations hydraulically, storage wise, no problem. But when it comes to the species of a plant to take up pollution is maybe a bit of a stretch for me.
Thank you. One from Mike Smith. So in your experience, what do you think the biggest challenges outside of cost there are when trying to achieve SuDS within a development? When you're engaging with a local authority, what could they do better to help the process of a scheme?
Oh, that's an unfair question by a colleague, an ex-colleague. Early engagement is absolutely essential. Most of my schemes that are successful is because we talk to local lead flood authorities early and engage the client with that. We bring them on the journey because ultimately it's harder to sell that. It's a realism. It's the what other elements are impacting the scheme. Flood risk and drainage, if I lived in a perfect world, would be the only thing a developer would consider, but it's not. It's transport. It's all of the other planning requirements, and having an appreciation within the local authority team of everybody else's. I'm not saying it doesn't. It's just, yeah, a focus on water quality is that the right focus for that particular site, or a focus on quantity, which has always historically been the case? How much storage do I need? It's £300 a cube, whatever. I'm talking quite candidly. When actually the storage isn't the biggest issue, they may have a water quality issue downstream that you say, could I improve water quality by doing X, Y, and Z? But we have a discussion on, because flood risk isn't a big issue. That would be a very mature and challenging discussion, given flood risk is only going to get worse. However, there may be opportunities where flood risk is outweighed by water quality.
I guess I'll follow up on that. So I mean, the weather conditions that we're seeing at present, they're getting worse and worse. Do you see that the planning and the regulations that are in place currently are sufficient to be able to meet some of those extreme weathers that we're seeing?
Rainwater harvesting tanks will always run out of water. And I think we probably have to accept that your grass isn't going to be green all the time. But encouraging rainwater harvesting is, I'll get shot down by developers on the call, is something we do need to consider. It's there in black and white now. I've got to give a reason in my reports why we're not doing it. Is that enough reason? I don't know. It's how stringent the officer is, how important they view it, and it may be viewed by one officer very differently to another. So that consistency is key, and that's why I do try and take people on the journey.
Brilliant, thank you. So a question from Richard Pearson: should more storage be provided through new reservoirs and reinstating the capacity of existing ones through dredging? This will also increase resilience in water supply.
Personally, I agree on the water supply resilience, and obviously reservoirs haven't been built for a number of years. In terms of impacting on developments themselves, I'm not convinced that storing water during a high river event would then make up for flood risk downstream. It'll do a certain amount, but it won't be the answer. So I'm not sure on a developer basis or development basis, site by site, that it would be hugely beneficial. But from a water resilience perspective, yeah, I'm aware of the scarcity and the issues that a lot of water authorities are having. So yeah, and the dredging, it used to be done a long time ago to provide capacity. Money now isn't as widely available, needs to be spent in other areas. So yes, in terms of hydraulic capacity, it's great, but is it going to impact on ecology and other elements that we now know we have to consider, whereas 60, 70, 80 years ago, we probably didn't have as much awareness of the impact on them.
Apologies, James, I just lost you there for a minute.
That's all right.
It's sod's law. It got right to the end of the webinar, and then and then it cut out on me. So just one final question here from Beth. Do flood resilience capital schemes and river embankment works have an impact on the type of SuDS designs that are being accepted by planning authorities?
Not in my experience, but I tend to work for developers, and therefore we tend to have to ignore benefits from wider schemes. Flood defences in particular, for example, it's residual risk, but we can't rely on flood defences in the schemes that we're working on. So from Castle Hill and around Hull, the benefits that brought, fantastic, but it has limited impact on schemes that we're working on. But I'm happy to be stood corrected on that one if it's not the case.
Okay, well, we'll leave it there. So thank you very much, James, for that presentation. For all of our participants, thank you for joining today. Just a reminder of the next webinar, which is held on the 28th of July at 11 AM, which will be held by Mike Raven, and that is on integrating sustainability within construction procurement. So once again, thanks everybody for joining, and we'll leave it there for today. Thank you.